AI agents. Literally everywhere you look right now, everyone's talking about them, right? There is so much hype and honestly a lot of confusion. We hear people talk about the AI like it's just this one giant monolithic brain doing everything all at once. But that is just not how it works in reality. If we really want to understand where this tech is headed, we've got to look under the hood. So, welcome to this explainer. Today, we're going to clear up the confusion by breaking down 12 completely distinct foundational AI agent architectures. We'll take it one clear idea at a time, looking at exactly how they tick so you can see the actual building blocks of the next generation of computing. To keep things simple, we've organized this explainer into 4 evolutionary buckets. First up, the solo improvers. Then, the team players. Next, the real-world doers. And finally, safety and partnership. Let's jump right in.
Part 1, the solo improvers. This is all about inward-looking AI.
You know, before an AI can effectively work with us or venture out into the messy real world, it needs architectures that help it look inward. These are systems designed to critique, adapt, and literally improve themselves. I mean, one of the biggest frustrations we all have with AI right now is errors, right? Hallucinations, mistakes. But what if an AI could catch its own mistakes before you ever even saw the output? Think of a truly great writer. They almost never publish their first draft. They write it, step back, look for the weak spots, and then they rewrite. Well, that brings us to the reflection agent. Here's the exact loop of how this works in practice. First, it generates an initial answer. But instead of just stopping there and showing you that rough draft, it feeds that answer straight back into itself and critiques it like a harsh, unforgiving editor. It spots its own logical flaws or notices missing context. Then it rewrites the answer using that exact critique. And it just repeats this process until the output is solid. The big idea here is honestly profound. An AI forced to systematically review itself makes way fewer errors than one that just blurts out its very first thought. Okay, let's dive right into this next one, because it takes that whole concept of self-improvement and applies it to the very code that runs the AI. Meet the self-evolving agent. Imagine a program that can literally open its own source code, find its weak spots, and ship a better version of itself. It inspects its own prompts and code, proposes an improvement, and then, this is absolutely crucial, it benchmarks its new self against its old self. If the new version is measurably better, it adopts the winner and repeats the cycle. This creates a loop of recursive self-improvement that compounds over time, with zero human intervention. Wild, right? But what drives discovery when there's no specific goal or external reward? Well, for that, we have the curious agent. Just look at this quote. Watch a child in a new playground. No instructions, they're simply drawn to whatever is most surprising. This agent basically operates by exploring its environment without a rigid objective. It measures how surprising new information is and treats that surprise as its reward. By formalizing curiosity like this, the architecture fuels endless open-ended discovery, pushing the frontier of its knowledge outward, completely organically. Moving on to part 2, the team players. This is where they start working together. So once we have these highly capable, specialized AI agents, the next logical question is, how do we get them to work together to solve complex problems that are just way too big for any single AI? Well, we have 2 totally different philosophies for teamwork here. On one side, we have the orchestrator agent. Picture a classical music conductor. They don't play the violin or the flute. They break the big goal into smaller tasks, delegate them to the right specialists, track the progress, and merge it all into one final result. It's very top-down management. On the flip side, we have the swarm agent. And this is completely different. Think of an ant colony. No single ant is super smart or in charge, but by sharing one goal, splitting the work, and running in parallel, they build vast, complex structures. The intelligence emerges from the bottom up, from tons of simple parts working all at once. Sometimes, though, the problem is that we don't even know what the single best answer looks like. That's exactly where the quality diversity agent comes in. Think about nature. Nature didn't just evolve one single perfect animal to live literally everywhere. Instead, it filled every possible niche with a different champion. This agent works exactly the same way. It mutates an existing solution, scores both its overall quality and its unique style, and keeps only the local best for that specific niche. The key takeaway here is that this architecture explores many strong and entirely different solutions all at the same time, giving you a whole map of possibilities rather than just one rigid single answer. All right, part 3, the real-world doers. It's time to interact with data. These architectures are what finally allow an AI to step out of the theoretical realm and interact with our specific data, our actual tools, and our very messy, unpredictable real world. Now, one of the biggest complaints about standard AI is amnesia. Why does your AI forget literally everything about you the second you close the chat window? The memory agent solves this. It actively captures what's actually worth keeping from your interactions, stores it in long-term memory, retrieves what's relevant to whatever task you're doing right now, and smartly forgets the stale, outdated stuff. It keeps the gold. By remembering your preferences and your past projects, this architecture turns a simple, disposable tool into a true companion that grows and gets better over time. Then, of course, there's the infamous problem of AI hallucinations, when an AI just confidently makes things up. To stop this, we use the retrieval agent. I absolutely love the analogy here. Think of a careful scholar. They never speak from memory alone. They check the source first. This agent takes your question, turns it into a targeted search query, retrieves the absolute best passages from external databases or your own private documents, and answers only from those sources. And crucially, it brings the receipts. It grounds every single answer in real, citable evidence. No more guessing. Taking real-world doing a step further, we have the software engineer agent. Now, this isn't just answering questions anymore. This is doing actual complex labor. Picture a brilliant senior engineer who can read an entire massive code base before you've even finished your morning coffee. The workflow here is just incredible. It reads the user's issue, finds the relevant code, reproduces the bug, carefully writes the fix, runs the test to make sure it didn't break anything else in the process, and finally opens the pull request. From a simple ticket to a fully merged fix, this is rapidly becoming the most deployed agent architecture in the enterprise world today. And that actually leads perfectly into our next concept, which expands AI beyond just code and text. Meet the computer use agent. Think of this as having a brilliant intern on a continuous screen share with you. This agent can literally look at your screen, take a screenshot, reason about what visual elements are present, and then actually move the mouse, click buttons, type text, and scroll. It works across any application, even clunky legacy software that doesn't have an API. The big idea here is wonderfully simple. If a human can use the screen, so can the computer use agent. It's a real game changer.
Finally, Part 4, Safety and Partnership, Keeping Humans in the Loop.
So, we've covered a lot of ground, and we've built some incredibly powerful tools so far. But that brings us to the architectures that protect us, set the boundaries, and ensure that human brilliance stays absolutely at the center of the loop. When you have a whole team of powerful AI agents executing tasks, who keeps them on track? Enter the Guardian agent. As the quote says, think of an air traffic controller. They never fly a plane. They keep every plane safe. The Guardian agent sits right above the others. It monitors every single action the other agents try to take. It checks those actions against strict, predefined rules. If it sees something unsafe, it blocks it instantly. And if it hits a gray area or a high-stakes decision, it escalates that hard call directly to a human being. This ensures safety is enforced live while the whole system is running. So the crucial point is right here. Is the ultimate future of AI about replacing humans? Absolutely not. It's about teaming up with them. This is the Centaur agent. The name actually comes from freestyle chess, which proved years ago that a strong human steering a strong machine will consistently beat a machine alone or a human alone. In this architecture, the machine acts as the engine. It drafts the work and processes all the heavy data. But the human judges, steers, and injects creative intuition. The hard calls flow to the person. Each makes the other radically better. At the end of the day, the most powerful architecture isn't artificial intelligence, it's a partnership.
And there you have it, the complete arsenal of all 12 architectures we've decoded today. From reflection and memory, all the way to swarms and centaurs. But the absolute most important thing I want you to take away from this explainer is that these 12 are not rifles. They aren't competing to be the one true AI. No, they're complementary building blocks. In fact, the absolute best systems in the world today combine them. You might have an orchestrator delegating tasks to a retrieval agent, all while being safely monitored by a guardian. The combinations are endless.
Honestly, the best way to truly understand AI agents is to just build one yourself. You've got 12 distinct architectures at your fingertips now. The real secret? Start incredibly simple. Pick one problem, apply one architecture, and then just compose and layer them as your needs grow. The tools to build highly capable collaborative systems are quite literally right here. So the final question I'll leave you with today is simply this. Knowing what these building blocks can do, what are you going to build?